name is Darryl Dwayne. We have a very special presentation for you. The Chromatics are a high energy vocal band on a mission to delight audiences with a full spectrum of songs about science, technology, and astronomy. Our Community Day programs are made possible with the generous support of our funders. Thank you to Horizon Foundation for New Jersey of their continued support for our family programs and the New Jersey Department of Community Affairs for their additional support. If you have any questions during the program, please use the Q&A button at the bottom of your screen, or if you are on Facebook, you can add a comment in our comment section. We will try our best to make sure to answer those questions live. We're going to hear some of their songs in a moment, but before we get into the show, I want to turn it over to Patty really quickly and just kind of check in to see how everybody is doing. So first and foremost, Patty, how are you?
I'm doing great today, Darryl. Thank you. How are you doing?
I'm good. I'm excited. I've already had a sample of a little bit of what you all are going to be doing. So I'm super geeked. I'm hoping that our viewers are equally geeked about some of the cool things they're going to hear in a second. But I guess at this point of the show, I'm just going to turn it over to you and the Chromatics, and you all can take it away.
Okay, thanks, Darryl. Well, you gave us a really good introduction. We are the Chromatics. We are an all-vocal a cappella band. And we sing songs about many, many things, but one of the things that we sing songs about is something that's very dear to our hearts and our lives, and that is astrophysics, astronomy, and space science. So we have a project called Astro Cappella. We are on a mission to bring science to the universe through music and to infuse music and science together. So we're really, really excited to be here as part of the Newark Museum of Art's Astrofest today. We think it's a perfect match for what we do. So we're happy to meet you and see you today, even if it's in a virtual format. You know, in a normal times, we would love to be there live, but that's not possible these days. We're all looking forward to when that could be the case again. But at the same time, we're really excited to be checking out this virtual format with you. So what we're going to do today is to tell you a little bit about Astro Cappella and our group as a whole. We'll describe what we do. We're going to sing some songs that we wrote ourselves, and the songs are educational. They're also meant to entertain. So in addition to doing lots of performances at science museums around the country and in the DC area, which is where we're from, all of our songs are perfect for classroom use. We're going to talk to you a little bit about how you can find out more about the lessons that go along with the songs and how you can use them either in a classroom setting or just at home with your students who may be home with you. So as we said, Astro Cappella is spreading the universe through song. And we like to talk about everything in the universe and how we know it. And we have a very strong connection with NASA. Many of us work with NASA and we do space science. So we're going to talk a little bit about those missions as well. And we're hoping to take you on a journey through our own galaxy, maybe even to the edges of space and time today. And we can talk about everything that's out there and how we know what we know. But we're going to start real close to home. We're going to start in our neighborhood to meet some of our nearby friends and neighbors right here in our own backyard.
I'm a big hot star, but it's not just me. I got a lot of little planets in my family. Sure, you know me well. I'm your stable, bright sun. But let's talk about my friends now. They're a lot of fun. 1, 2, 3, 4, 5, 6, 7, 8. How many planets are circling in a plane? And everyone is different. Now let me just explain. Rolling around on their orbits like the tracks for a train. Oh yeah, they're dragging around the sun again and again and again. 1, 2, 3, 4. Mercury's a hot spot, the sun is so close by. Venus like a diamond shining in the Earth's sky. Next is your home planet, the place of your birth. It's the solar system garden spot, the precious planet Earth. Now Mars is red and rocky with some polar ice. It's a song about the atmosphere. It could have been so nice. It could have been so nice, so nice. They're the terrestrial planets. 1, 2, 3, 4. But you gotta wait around, cause there's gotta be more. 5, 6, 7, 8. How many planets are circling in a plane? And everyone is different. Now let me just explain. explain. Rolling around on their orbits like the tracks for a train. Oh yeah, they're chugging around the sun again and again and again. Jupiter's a giant ball of gas like a sphere with a red spot. It's a storm that's raged for hundreds of years. Saturn in the night sky looks so bright and so little, but with the telescope you'll see a ring around the middle. Uranus is tilted on its side in the plane. Neptune's got another storm with chemical rain. They're the gas giants, 5, 6, 7, 8. But there is still more, so you gotta wait. Off of the edge, it's Pluto, our little caboose. Everybody knows it's Pluto. Maybe a slingshot round the giants almost set him loose. Or it's a giant in the Kuiper Belt. Yeah, there's a mystery about to unfold, with rocks and ice and chunks of things now very old. How many planets are circling in a plane? And everyone is different, now let me just explain. Staying in their orbits like the tracks for a train, chugging round the sun again and again and again. 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 Again and again and again.
Hi, yes. That's Astrocapella is a project very near to our hearts. We love the combination of astronomy and song and being able to educate and entertain at the same time. And we love putting that little show together there. Our Astrocapella CD and materials are in use in schools all over the country and overseas. And our CD has even left the planet, believe it or not. Yep, our CD has flown in space. I think we have a slide of that. Yep, there it is. This is John Grunsfeld. He's aboard the space shuttle with the first version of our Astrocapella disc. And this was STS-103, a Hubble Space Telescope servicing mission all the way back in December 1999, because we've been doing this a long time and we've been enjoying every step of the way. So how about we introduce ourselves? I'll start. I'm Alan Smale. I'm the red chromatic and I sing bass very low. In my day job, I work at the NASA Goddard Space Flight Center. Several of us do. And there I'm an astrophysicist and I study neutron stars and black holes. And I also manage a data archive. And with the other third of my brain, I write science fiction and alternate history novels. Scott, who are you? Over to you, Scott.
Yeah, I'm Scott. I'm mute. I'm Scott Rohrbach. I'm an engineer. Yes, I'm an optical engineer. I also work at NASA Goddard Space Flight Center. I've been working on the James Webb Space Telescope for the past decade or so. I'll show you a very quick little. That is the primary mirror of the James Webb Space Telescope. It is enormous. I'll tell you about that a little bit later. On over to Karen.
Hi, I'm Karen. I work at the NASA Goddard Space Flight Center also, and I build websites for scientists to help them do their jobs. And for the Chromatics, I sing mostly alto and soprano.
And my name is Michelle Orhan. I'm the purple chromatic. I'm actually a junior high middle school math teacher. Love teaching math, and I am the alto of the group, although sometimes I have been known to sing soprano. Over to you, John.
Well, I'm John. I work at Johns Hopkins Applied Physics Lab just up the road from NASA Goddard. I work with space satellite power systems and ballistic missile payloads. I sing bass, baritone, and do vocal percussion. And last but not least is Patty, our director.
Thanks, John. My name is Patty Boyd, and I'm an astrophysicist at NASA Goddard Space Flight Center, which is in Greenbelt, Maryland. And I've been working there for the last 2 decades or so. I've worked on a variety of space astrophysics missions, starting with the Hubble Space Telescope, which is still going great on orbit 30 years after launch. I've also worked, also worked on a mission called SWIFT, which goes after gamma ray bursts, which are the most energetic explosions that happen at the edge of our known universe. So we can learn about what they're telling us from clear across the universe. And I've worked on the Kepler mission, which was NASA's first mission put in space to discover exoplanets, and it discovered thousands of planets around other stars. So we always wondered when we looked up at the night sky, would those stars out there be similar to our sun? Would there be planets around them? And for thousands of years, it was just a big question. And, you know, science fiction writers, TV shows, movies, philosophers, everyone dreamed, including scientists, of what it would be like if there were planets around other stars. But we thought for so long that it would never be possible for us to know because they're very small and they're very dim compared to the stars that they're around. But our technology has improved, always improving, and our telescopes have gotten better and better, and our methods have gotten better and better. So Kepler gave us the best answer we could have possibly hoped for to the question of, are planets like Earth common or rare around stars like the sun? Kepler tells us that planets are everywhere, and small planets are very common, and many of them are in the Goldilocks zone, where liquid water could pool on the surface, which we think is one of the key ingredients to life. And so we were taking steps towards a search for life that's very exciting. I now work on a mission called TESS, which takes the next step, which is if planets are everywhere, let's find the ones that are nearby around bright stars so that we can study them even further. So we're going to talk to you a little bit about the fact that we are on a journey. We've gone outside of our own solar system to look for other solar systems. We've found thousands of them already, and we're on a journey that we're going to find thousands more in the next few years.
When I was a child, I tuned into a beautiful fantasy. Humans and Vulcans at peace in the cosmic community. I'd look up to the sky at night, and I'd ask myself, could it be right? Are there planets like ours around faraway stars? Or are we all alone on a planet of hope? Are we whirling around imperceptibly, caught up in the dances of gravity? A random galactic anomaly, 9 planets around the sun, spinning and swirling, twirling and whirling around the sun. Time marches on and astronomers hone their technology, point their scopes to the sky with an eye to unraveling a mystery. And like the faintest of calls in the night, lies a signal within a star's light, like a beacon of hope in your burnt umber sky. The rising of 51 Pegasi, dancing almost imperceptibly, backward and forward from gravity, a companion of closest proximity, a planet around a star. At the edge of the galaxy, clusters of stars, their members a billion years older than ours, hold wobbles of planets around their pulsars. They've had eons more time than we. Is it possible? Could it be? Am I watching you, watching me? And with more planets than stars in the galaxy, the dream has become a reality. We're not quite as alone as we used to be. There are planets around the stars, planets around the stars, spinning and swirling, twirling and whirling around the stars. Backward and forward, they're coming and going around the stars. Daytime and nighttime, summer
So that was Dance of the Planets. And that was performed in Goddard's massive centrifuge, which is a test facility that's been used for a long time to test stuff that's getting ready to go into space. And it's shaped in a large cylindrical shape, and that gives you an amazing reverb. So we were really happy to be able to sing that song in that space so that the reverb, I hope that you heard it, could actually be reinforced by the shape of that space. So it's really cool to use a science space in a way to get some cool music in there as well. So we mentioned that exoplanets are everywhere, and this is a really exciting development. When I was a young scientist, we only knew the planets in our own solar system. And now, just a couple decades later, we now know that there are actually more planets than stars in the Milky Way galaxy. And we're on a quest to detecting those that are closest to us so that we can follow them up, because brighter stars are easier to follow up with bigger telescopes on the ground and in space that will allow us to learn more about these planets. Not just that they're there, which is what Discovery tells us, but what are they like? If they're small and rocky, do they have an atmosphere like the Earth? Or maybe they have an atmosphere like Venus, or very little atmosphere like Mars? Is there any way we could try to tease out some of those details about what these planets are like as places? We need giant telescopes on the ground in space to help us do that.
Yes, we do, Patty. And as she mentions, giant telescopes are the way to go if you're trying to look for tiny, tiny, tiny little details out in space. The James Webb Space Telescope is something I've been working on for the last decade, like I said. And a picture behind me here is the primary mirror of the James Webb Space Telescope. It's 6.3 meters in diameter. It is so enormous that this guy in the picture barely shows up. If he laid across the mirror, he would barely cover one of these 18 hexagons in the primary mirror. This thing is enormous, and it's going to see back 13 billion light years to near the beginning of the visible universe. So we're really excited about this. It's going to launch in the next year. Thankfully, Hubble is still up there, so we're going to be able to get multiple observations with James Webb and Hubble and other telescopes out in space to do cross calibration. It's going to be the greatest thing. And one thing that we all know about telescopes is they're time machines. They bring us back in time. This one's going to bring us back almost all the way to the beginning of the visible universe. James Webb is going to be the biggest time machine of all.
Get up.
Get on up.
Get up.
Get on up.
JWST.
Get on up.
Launching into space.
Get on up.
Biggest thing you ever seen.
Get on up.
It's a time machine.
Get on up.
Let's do it. Hey! 6-meter mirror on a 1,000,000-mile trip, observing in infrared wavelengths to reach the highest redshifts. It'll be the biggest telescope in space. Gonna see 13 billion light years away. The James Webb Space Telescope launching into space. Biggest thing you ever seen. It's a time machine.
6 times larger than HST, 32 megapixel camera and spectroscopy, cool clear absolute zero, minus 400 degrees, for best image quality, low self-emissivity, from planets in our solar system to the early universe's conditions, the James Webb Space Telescope.
Interstellar dust clouds block all sorts of light, but in mid-infrared wavelengths the universe is clear and bright. From the end of dark ages to the very first light, pre-ionization will be quite a sight.
JWST launching into space. Biggest thing you ever seen. It's a time machine.
With the infrared camera we'll see the first stars start to shine. And then for clusters of galaxies, universal building blocks all combine. We'll study black hole morphology and redshifts very high. Dark matter distribution and proto stars just come into life.
Active dark windows block out bright stars in view. So we see distant faint objects and measure spectra of them too. By viewing only objects that we want to see, we'll split light from 100 targets
Simultaneously.
JWST, launching into space. Biggest thing you ever seen. It's a time machine. Let's wrap it up.
Now J-Dub is more than just the first galaxy. It'll study nearby exoplanets, possible local homies, by phasing out bright starlight with interferometry. We'll observe orbiting planets and be able to see their atmospheres as they pass in front of their stars and capture light that's not absorbed by things like water vapor.
That's the telescope we call JWST, launching out of this world. Biggest thing you ever see. It'll be the biggest telescope in space. Gonna see 13 billion light years away. The James Webb Space Telescope.
So that video you saw there actually was a video of a performance we did at the Kennedy Center last summer. The Kennedy Center in Washington, D.C., here where we're all from. So last summer we were invited to perform in conjunction with the 50th anniversary of the Apollo 11 lunar landing. It was just an absolutely beautiful day and beautiful night, and we were so honored to be asked to be part of those celebrations. So when we started the Astro Capella project, we really realized that in order to get this out there to students, that we needed guidance from educators to understand the best ways to bring this music to life in the classroom. And we really wanted to share that passion that we have for space and for the universe with everybody we could possibly reach. So we found and we met with expert educators, and we collaborated to create lesson plans that would bring these songs to life. So we've used these songs like How Many Planets, which you saw at the beginning, and Come and Visit Mars, which you're going to see in a few minutes, to help elementary students, our younger students, to access the universe and see the beauty that our universe holds. And we have other songs like JWST, which is about the James Webb Space Telescope, which you just heard, and Swift, which Patty talked about earlier, which is about a space observatory. And they're geared towards older students to allow that learning to really continue in the classroom and through music and through science teachers. It's so important that our kids access education in so many different ways. And we want to be one of those ways that children learn about these beautiful things in the world. So with all the lesson plans we have put together, we have these great activities that can help teachers or parents at home make our songs come to life. My personal favorite is about the phases of the moon, right? So we see that beautiful moon up in our night sky so often, every day. And really all you need to do to recreate it at home is find a ball, a stick, and a source of light. And with a few easy steps, you can make the phases of the moon pass by right in front of your eyes from the comfort of your own home.
Cool. Yeah, that's awesome. The moon is very close by. It's our nearest neighbor. And since everyone can see it, it's a really cool and convenient way to teach people about science. I was personally very happy to perform at the downtown for the Apollo 50th celebration because I've always had a thing for the moon, and it was a great show that night. I watched the Apollo moon landings as a kid, and they changed my life. I wouldn't be here today doing all the things I'm doing without the influence of the Apollo program and the astronauts and that. I do have to admit that when I was a kid, I thought by now I would be living on the moon, but I guess we don't always get quite what we want. However, now we as a country and as a species are now planning to return to the moon. NASA now has a new plan for lunar exploration. appropriately named the Artemis program, and that's named after the twin sister of Apollo and the goddess of the moon in Greek mythology. And under the Artemis program, NASA aims to land the first woman and the next man on the moon, maybe as early as 2024, followed by a sustained human presence on and around the moon by 2028, as well as launching dozens of robotic payloads to do all kinds of science in various areas on the moon where human feet won't get to tread yet. And I'm really looking forward to that. If they happen to need a theme song, we have one handy. I wrote a song about the moon some time ago, and this is it. This is Lunar Love.
My love's a 250,000 miles away, and she's 7,000 miles around. When I'm walking on her surface, gravity's 1/6 of normal, so my feet don't hardly touch the ground. From her mares to her uplands, from her basins to her craters, she's the shining sphere that dominates my dreams. We're orbiting together round our center of attraction. Now my days and nights are coming up moonbeams. What goes around comes around, you know it. Don't tell me that my love is just a phase. You may think we're on the wane, but time will show it. We go from fall to new to fall in only 29 days. There's a craziness about our sweet attraction. There's a side to you that I don't ever see. But your tidal forces keep my ecosystems running high. Let me shelter in your sea of tranquility. Let me shelter in your shining lunar sea. I'm not the only man this side of Mars to get my heart so dazzled by your charms. You've been the guiding light to many sailors and astronomers, but none of them has held you in his arms. Don't talk to me about our little difference in ages. What's a mere 4.6 billion years? They say you have no core, nothing solid at your center, and a lack of atmosphere just makes a girl so insincere. What goes around comes around, you know it. Don't tell me that our love is just a phase. You may think we're on the wane, but time will show it. We go from new to fall to new in only 29 days. There's a craziness about our strange attraction. There's a darker side to you that I don't see. But your tidal forces keep my ecosystems running high. Let me shelter in your sea of tranquility. Let me shelter in your shining lunar sea.
Michelle mentioned some materials on our website. We actually have 2 websites, I guess because we're overachievers or something. We have a Chromatics website, which is thechromatics.com. And that site will tell you a little bit more about the group and about all of our recordings. We don't just sing science songs, and when and where we'll be performing. That part of the website maybe hasn't got too much on it at the moment, but we're hoping for more virtual performances like the one we're doing tonight. If you visit our Astrocapella website, and that's astrocapella.com, you can also link to it from the Chromatics website. You can find all the materials that are related to these science songs that we're doing. So the activities and the lesson plans for each of our songs are there. Michelle mentioned that. Plus there's background material about the topics of the songs. So if you're a parent or a teacher, you could learn more about the things connected to our songs, like how we think the moon was formed or how the Doppler shift works. So these pages could help answer questions you might get from your children or your students. These backgrounder pages also have links to further resources on NASA and other websites. For some of the songs, we even have MP3 files on the website and the lyrics, so you can actually listen and sing along if you want. And there are links to some of our videos on YouTube, so you can see and hear more there, some of the ones you've seen already, and also including, for instance, a completely different video for the Dance of the Planets song you heard us sing earlier in the NASA Centrifuge. We use a lot of NASA imagery in some of our videos, but we've also worked with others to develop videos in a completely different style. John?
Well, you've heard us talking about working with teachers. We wanted to try something different. We wanted to get one of our songs animated. And we found someone at MICA, the Maryland Institute College of Art, who was willing, figure that, to animate one of our songs. And he picked this song about Mars. And I know at least one of you out there with us now will be on the surface of Mars within 25 years. Woo. So you should pay attention to this animation because it gives hints and advice about actually being on Mars.
Come and visit Mars, you can have a lot of fun. We're right next to Earth, we're the fourth planet from the sun. Although we're half as large as Earth, we offer quite a lot. Huge mountains, craters, rifts, and storms.
Much larger than Earth, Scott.
Olympus Mons, a huge volcano visited, of course. 3 times as high as Everest, wide as Pittsburgh to New York. Bring a coat and bring a hat to bundle if you please. Our temperature gets rather low,
Minus 200 degrees.
'cause our orbit is eccentric with a thin atmosphere, which you'll enjoy 687 days per Martian year. Just as a note of caution, it's not a big to-do. There's hardly any oxygen.
It's mostly CO2.
There's also not much pressure, so your body may explode. It's less than 1% of that of Earth, so wear the proper clothes. We hope you'll come to visit, and we hope it's very soon. We've Phobos and we've Deimos,
2 very lovely moons.
we're terrestrial, we're inner planet, not too far away. We see you sent ahead, some things, come pick them up someday. Come and visit Mars, you can have a lot of fun. We're right next to Earth, we're the fourth planet from the sun.
So that was the Come and Visit Mars animation, which was developed by the MICA professor. So that was another way that we've worked with educators. And I think it's really cool that we've had the chance to work with educators in math, educators in animation. We've also had the chance to work with educators who are interested in using the songs to support concepts in, say, middle school and high school math and science classes, because much of what we learn about the universe is through fundamental concepts that you also learn in physics, like gravity, or like chemistry, the way that we tease out the elements that make up objects and astrophysical objects by looking at their spectral signatures. That's all chemistry. And we've worked with teachers also who are interested in bringing the songs into the elementary classrooms. And so our songs also are separated into those that are more appropriate for the older grades and many that are more appropriate for the younger grades. And so, for example, the Come and Visit Mars video was actually pitched towards a younger audience. And so it's meant to, really entice younger minds. And many of the songs that we sing about solar system objects, the planets, the sun, the moon, Mars. These are also designed to be used in elementary school classroom settings because many elementary school science classes do cover the solar system and Earth science. And we've also been pretty careful to make sure that our songs stand on their own. So even though there are songs that have background material and all kinds of NASA imagery to support them, activities, games that you can play, we also want to make sure that the songs are entertaining and that they can get a message across about what we're learning about the universe and how we learn it, why telescopes in space are like so amazingly transformative in how we can learn about the universe. So I hope we've been able to give you a little taste of what we do and why we do it. We are more than happy to talk to you in the Q&A after this, answer any of your questions. You can find out more about us, as Karen said, on the web. We also have a Bandcamp site where you can download our Astrocapella CD and many of our other CDs. We have more than half a dozen CDs that we've recorded. Some are based on science, some are not at all. Many of them include original songs that we write. And we continue to write new songs about things in space or just things in the world at large, the hearts and the minds of people here on our planet. So please find us online if you'd like to. Stick around and ask us some questions here. We're happy to do that. We are hoping that we taught you a little bit about our universe. We did go beyond the solar system a couple times, but we're going to bring it right back to some of the most amazing things that you can see when you look up at a night sky. So we just passed the Leonids meteor shower earlier this month, and we're looking forward to the Orionids in December. I know I grew up in New Jersey that it's sometimes pretty hard to find a dark sky where you can see meteors in the sky, but it's worth the trip. And if you've been lucky enough to see something, a shooting star in your sky or a comet, you know, like how that can really capture your attention and not only make you think about our place in the universe, but how we learn these things. So we're going to cover some of the differences and similarities of those types of objects that you might see in the night sky in our closing song. It's been our pleasure to sing with you today in this virtual format. So we're going to leave you with a little bit of rock.
Hey baby, I'm a shooting star, a blazing racing tracer in the sky. I'm heading for the surface 50,000 miles an hour. Gonna hear my sudden impact, gonna feel my power. Catch you later when I crater. I'm just a little bit of rock.
There's one of us who went down all the dinosaurs. We're icy bits of comets, we're iron and we're rock. Streaking through the sky, we're an atmospheric shock.
Hey baby, I'm a rock in space, a jumbled tumbling body in the sky. Between Jupiter and Mars I make my presence felt in a band of rocky relics called the asteroid belt. Pallas, Ceres, Vesta, and many thousand bits of rock.
Small bodies where the asteroids, unless a planet decimals are swinging in the void. Chunks of constellations or a tiny world unformed. Watch out through the earth crossers, you have been warned.
Hey baby, I'm a hunk sublime, an icy dirty snowball in the sky. Gases streaming from my nucleus give a nighttime treat. I'm a dropout from the odd cloud with a regular beat. Eccentric in my orbit through the solar plane. Pass too close to sunward and I'll never be the same.
Small bodies where the comets hunt, tails forever trailing away from the sun. Young Kentucky high and a bit of pale pop. SL9 hit Jupiter, that show was not a flop.
Rocking round the system with small bodies, right? We're asteroids and comets and we're difficult to sight. If we plunge into your atmosphere, we set the skies alight. Then we're meteors and fireballs, you'll glimpse us in the night. Just a little bit of rock.
All right. That was amazing. I'm still over here jamming to a little bit of rock. I was over here. The course was simple enough for me to learn, so I'm over here just singing along. If you're looking for a 6th or 8th member, just let me know. I truly enjoyed this. And by the audience commentary, they look like they enjoyed it just as much as I did, as I've been over here rocking out through the whole show. So if any of you have ever seen any of our programming where I've hosted, I am kind of known for throwing curveballs. So I would be remiss if I did not ask this question before I let you all go. And that question is, since you all write songs about space and create these amazing melodies that encompass science, I want to know from you all, and feel free if everyone does sort of a round robin on this question. What is your favorite space pop song, if you have one, and or what is your favorite space movie? I mean, again, I know like you probably weren't expecting questions like for that from me, but I couldn't have you here and not ask that. So I guess I could start with Scott. If you're ready, Scott. What is your, you can give me either or both if you have both.
I'm gonna have to say Big Bang Theory for the song, since we recorded it and it's on an album of ours. But I just listened to a podcast recently about the movie Contact, which was based on a book by Carl Sagan, and it's about the scientific approach and making first contact with an alien intelligence, and all of the politics that goes into that, all of the science that goes, all of the personalities that go into that, all the engineering. It's not like an adventure movie,
yeah,
in the way most science fiction movies are, but it's really intriguing, and I think it's really accurate about how things like this happen.
Okay, all right. Thank you for sharing. I'm gonna slide over to Karen and see what Karen's song and our movie, or both, is her favorites.
The movie is really easy and totally predictable. I've been a Star Wars fan since it came out in 1977, and I just love those movies, most of them. So yeah, sorry, very predictable there. For song, that's a little harder, and the songs that I like that are space related aren't necessarily about space, but they have kind of space titles, like Supermassive Black Hole, or Black Hole Sun. I mean,
yes, one of my favorites. yes. I love that song. I guess it might be showing my age as well to our viewing audience, but yes, I love Black Hole Sun. One of my all-time favorites. I'm going to go over to Michelle really quickly and check in on Michelle. What is your favorite pop song that may refer to space and or movie?
I think Scott stole my answer there. I was thinking Big Bang was the first thing that came to my mind too, because it's one of the few songs that really does talk about, right, what's happening out there. But as for movies, I think I speak for all of us when I say we're all kind of Trekkies, right? Love Star Trek, and in every iteration. Yeah, and Doctor Who is my other, right? Like the beauties of what our universe holds that we just don't know, I think is just fascinating. And to see that, one day, long after we're all gone, right, that we might be traveling through space, meeting other cultures. And, it's just fascinating to see and think about what's out there.
I love that. I'm going to pass it over to Alan now. So Alan, feel free to chime in.
Okay. Yep, as far as music's concerned, I always like Space Oddity by David Bowie, and there's a lot of other Bowie music that seems very spacey as well. Space Oddity is kind of depressing, but it kind of fits in with the theme quite well. Tangerine Dream, a lot of their kind of music, although it's not specifically about astronomy or space, it feels like it should be, a lot of that kind of instrumental music. As far as movies are concerned, I'm the guy who loves the moon, and so I'm going to tell you that I really love Apollo 13. They spent a lot of time getting the technology right on that, and if I couldn't go up in an Apollo mission, knowing what it would be like, I think Apollo 13 would teach me the nuts and bolts of what that would be like, although I wouldn't necessarily want the crises and explosions and life and death experiences thrown in on top of that. I'd like a successful moonwalking mission.
Yeah, I will have to agree with you there. I love that movie, but it's a mixed bag, right? Such great context for us who've never actually physically been in space, but again, the storyline is very emotional. So for anyone who hasn't seen it, I would tell you to check it out. Really great movie. I'm going to go over to John, and then I'll wrap up with Patty. So John, what is your insight on this movie?
Well, I like Babylon 5. Woo. And I'm with Alan on the Space Oddity thing very much. But other than that, it's like, if it's space stuff, I like it in general.
Yeah.
Okay. All right. I'm going to close out with their fearless leader, Patty. So Patty, what would be your favorite space pop song and or space movie?
So I definitely think the next song we're going to learn is Space Oddity, because I think it would be so cool to do that a cappella. But I want to give a shout out to a group called Great Big Sea, who wrote a beautiful song called Walk on the Moon. And it's basically taking that concept that like this was something that was so incredibly amazing for just a small number of people so far. But that what is your walk on the moon? You know, like what is the experience in your life that becomes your walk on the moon? So I thought it was just such a beautiful metaphor there. And as far as movies, no one's given a shout out to 2001 yet, but that was pretty epic. And just the beauty of the space shots and the mystery of what computers might do in the future. And I think it really stands the test of time. But I also wanted to give out a bit of a shout out to Contact also, because it has been an incredibly important movie for many, many women in astrophysics. It portrayed, its central character was a young astrophysicist. And there were many people in that movie that are based on real life astronomers. So she was actually based on an exoplanet scientist, a woman who worked for SETI, named Jill Tarter, who worked for SETI years before we even knew that planets were around other stars. She believed that you could, look for other life out there by their technosignatures, the technology. And the scientist who could listen to the radio waves and hear faint signals that other people couldn't because he was blind, actually a real scientist, and a great example of how we need so much diversity in science to really hear the whole picture and think the big ideas. And a lot of what happened in Contact happened at the Arecibo Radio Observatory, which is in Puerto Rico, an amazing radio observatory for generations. And it's just been destroyed by hurricanes and other unrest, awful things are happening to the site. And it's looking like now we're going to have to close down Arecibo. So that's really heartbreaking for a lot of astronomers. But seeing that, the movie will keep the legacy of Arecibo alive, I think is really important. So everybody go watch Contact.
Contact is another great space movie. You're all listing my faves. I guess you could tell I grew up in a sci-fi house. So with that being said, I just want to again thank you all for joining us and being a part of this. And I love the plug that you said, or the mention you said when you highlighted diversity. Diversity is so important. You all are a diverse group of individuals, and since we're on the topic of diversity, I know earlier we had Mae Jemison speaking, and not everybody was able to see that. So I want to remind our viewers that tomorrow, November 22nd at 2 p.m. If they missed the talk, or if they just want to watch it again, they will be able to watch the broadcast be rebroadcasted via the Newark Museum's platform. So definitely check that out. It should be on our Facebook with the Mae Jemison talk. And if you have any questions, you still can leave questions in the comment section, and we'll try our best as a museum to get those answers for you. So with that, again, thank you, Chromatics. I really appreciate you all. Again, thanks for the fantastic display of music and science. Let's first and foremost give a big round of applause to you all, because you all rocked it. So virtual again. Applause. Yes,
Thank you.
We hope that you all have enjoyed and learned something today at AstroFest. It has been an amazing day of astronomy and space. It has been truly out of this world, for lack of better words. Special thanks to our partners, ParaKids, Liberty Science Center, and the Intrepid Sea, Air, and Space Museum. Thank you for our supporters, the Horizon Foundation in New Jersey, as well as the New Jersey Department of Community. And I just again want to say thank you, Chromatics. You all were amazing. This is my first introduction to you all, so you left me speechless, and I can't wait to see what else you have on the horizon. Are you all on social media? I'm sure that's a question that some of us may, who are watching now, may want to know. What is your social media at for those who want to follow you to keep up with your upcoming shows?
We're on Facebook and Twitter, and you're asking me a question that I don't know off the top of my head.
I'm sure it's on your website. So if you all are interested in wondering what their ad is on their Instagram and Twitter, or Facebook and Twitter, go to their website and you should be able to get that information.
Yeah, again, and on Facebook, it's The Chromatics.
On Twitter, it's at Chromatics MD.
There we go.
Yes.
As in Maryland.
Maryland.
Yeah.
Awesome. Again, thank you so much. And we want to wish everyone a happy holidays and enjoy the rest of your weekend.
Thanks for having us, Daryl. It was our pleasure.
Thank
Bye.
you.
Bye.